Okay, good morning class. So we are talking about equivalent fractions today. You should have already copied some notes down in your math notebook, and if you chose, you could have watched the Brain Pop video on equivalent fractions. So now we're going to start looking at different models of equivalent fractions. So number 17 says, write the equivalent fractions represented below. So let's look at so what could we do for number 17 to see what fractions are equivalent? Anybody have a guess? What do you think, Allie?
Are we talking about like number 18?
Right here, number 17. What can I do?
Oh. You both underline the top.
Like this?
Mm-hmm.
Okay, so I see 1/6 right here. Does that match up with any 1/8 below it? Does it look like it's equivalent to 1/8?
No.
No, it doesn't match up. Okay, so let's keep going. If I go to 2/6 and follow it down, does it match up with any 1/8 strip?
No.
No. Okay, so I need to keep going. Now I'm at 3/6. If I keep following that line down, does it match up?
Yes.
Yes. So on your paper, I want you to do that. I want you to take your pencil and you're going to see that line. When you trace it, it follows the 1/8 line also. Okay, so let's shade in 1/6, 2/6, 3/6. Okay, so 3/6 is equal to, now we need to figure out how many eighths. So I'm going to shade in until I get to this line where we said they matched, right here. I'm extending it a little bit further so I can see. 1/8, 2/8, 3/8, and 4/8. So you see when I shade all the way to the middle, does it look like the same amount is shaded? Yes. So 3/6 is equivalent to 4/8. Okay, let's go to the next one, number 18. Write the equivalent fractions represented below. So what do I need to do first? It's not labeled, is it? So what do we need to do first? Aaliyah? Count the squares. Good. So on the very top, let's count the squares to figure out what fraction we're going to be talking about. I have 1, 2, 3, 4, 5, 6. Okay, so my denominator is 6. Okay, and down here I have 1, 2, 3. So we're comparing 6 2/3. Trying to figure out what is equivalent. Okay, so we're going to do the same thing. If I just shade 1/6, does that match up with 1/3? Does this line right here follow through and meet the edge of a 1/3? No, because it's way down here. Okay, so I go to 2/6. If I follow that line down, does it match up?
Yes.
Yes. So what does that mean?
That means there's 2/6.
2/6. Good. I've shaded 2/6. And it equals the same amount as what? 1/3. Good. So these pieces are equivalent. 1/3 and 2/6. Everybody good so far?
Yes. Yes, ma'am.
Okay. Number 19. Write the equivalent fractions represented below. So the top pieces have already been labeled for you. They're fourths. Now what do we need to do to the bottom first? Count all of the pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are comparing tenths to fourths. Okay, now I want you guys to try this one on your own. What would you do to see if it's equal, or how many pieces it would take to equal each other? Let's see if we were able to figure it out on our own. So I'm going to just start with the fourths. I follow the line down after 1/4. Does it meet up with anything? No, it's close, but it's not exact. Okay, so 1/4 does not equal anything for tenths. So we go to 2/4. I follow the line down. Does it match up with anything?
Yes.
Yes. So now I need to count or shade. So I have 1/4, 2/4. So 2 becomes my numerator for fourths. Now I need to figure out my numerator for the tenths. How would I do that?
Ooh.
Kelsey?
For your tenth, you would look at the bottom and you would count. Since the line's right there, you would count all the shaded on the bottom.
Good. I'm going to count all of these on the bottom. So there's 1, 2, 3, 4, 5 up until we get to this line. So 5 tenths equals 2/4. Can y'all think of what else this would equal? What do you notice? If I'm putting this line here, what did I do to all of my bars? Does it look like I cut it in half? Does it look like it's right in the middle?
Yes.
Yes. So we could also say both of those fractions are equal to what?
They're equal to 10.
They're equal to 1/2. Okay, because they're both right in the middle. Okay, so let's go to number 20. This time I have a whole piece and pieces at the bottom. So what do I need to do with these pieces at the bottom, Bryson? I'm going to count them first. So 1, 2, 3, 4, 5. So what does that tell me?
That's how you have. It's the bottom though.
It's the bottom. Good, the denominator. And we just have one whole. So we're trying to compare one whole to how many fifths? Well, how many fifths is it going to take to equal this whole bar right here? All of them, right? So 1, 2, 3, 4, 5 fifths. 5 fifths equals a whole. Okay? Anytime the numerator and the denominator are the same, that means it equals a whole, one whole. So now let's look at fraction circles. Write the equivalent fraction represented below. So I'm looking over here at the purple shaded one. And what fraction is shaded?
1/4.
1/3. Good. So 1/3. Can y'all see that? Move it over. 1/3. Now if I shade over this with black, does it look, if I take off that line in the middle, does that look equal to the purple? Yes. So if I laid those on top of each other, this piece that I'm shading black would equal this piece. Y'all see that? Okay. So how many pieces did I just shade?
2.
I shaded 2. So 2 is my numerator. Javea, what would my denominator be? because there's 6 pieces total. 1, 2, 3, 4, 5, 6. So 1/3 is equivalent to 2/6. Okay, number 22. I want you guys to try that one on your own. Does it look like the shaded pieces match each other?
Yes.
Yes, it's just kind of flipped around. It's the opposite sides that are shaded. So I want you to come up with the 2 fractions that are equivalent to each other. Let's check and see what you got. Or if you don't have anything yet and you're still confused, then just pay attention and listen, okay? So first I need to count all of the pieces right here, right? So there's 1, 2, 3, 4, 5. 5 is my, what do we call it?
Denominator.
Denominator, good. Now, the numerator is how many pieces that are shaded. So I have 1, 2, 3. 3/5. Okay, now I go over to this one. I'm going to count the total, and that becomes my what? Denominator. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then how many were shaded purple?
9.
6. 6/10 is equivalent to 3/5. The same amount is shaded. Okay, number 23. Write the fractions represented below and determine whether or not they are equivalent fractions. Okay? Does it look like the same amount is shaded?
Yes. No.
Some say no,
Yes.
some say yes.
Yes. No.
So, okay, well, we'll see. Let's look at the orange pieces. There's 2 shaded. And then how many total?
8.
8. So 8 is my denominator. Okay, now the next one, there's 1 out of
5.
5. Good, so 1/5. Okay, so now is where I'm going to show you a trick or a backup strategy when you cannot tell just by looking at the shaded parts, because sometimes it is hard to tell by looking at the shaded pieces if it's the same amount, right? This is probably one of them, okay? So the backup strategy is to use multiplication. So let's go back up here to the top, and I want you to notice what we're multiplying by. So if I have 1, I can multiply it times 2 to get 2, right?
Yeah.
So then if I multiply 3 times 2, does that give me 6?
Yeah.
Yes. So if you end up multiplying by the same number, that means they're equal. So let's look at this one right here, the second one. 5 times 2 equals what?
10.
10. So I need to see, does 3 times 2 equal 6? Does 3 times 2 equal 6, class?
Yes.
Yes. So they are equivalent. Okay, so over here, 1 times 2 equals 2, right?
Yes.
5 times 2 equals 10. So are they equivalent? No. Okay, so multiplication can help you. Okay, so let's look at the last one. Are they equivalent by looking at the shaded pieces? Yes. They both equal what?
A whole.
A whole. So over here, Allie, what would my fraction be for the purple?
There's 3, then 3 couples, and the next one
3
is
thirds.
1 out of 1. No, 1.
Just one whole, okay.
Yeah, 1 whole.
Can I use multiplication here too?
Yes. No.
Not really, because it's a whole. But we know that anytime the numerator and denominator are the same, that means it equals what? A whole. Okay? All right. Last last but not least, number line. We said when we took our notes, to be able to tell if two fractions are equal on a number line, they have to line up, right? So all you need to do on this one is follow the dots or the stars and see if they match up. Kind of like what we did with the fraction strips. We had to see if they matched up. Okay? So let's look at 21 together. I see my dot is at 1/3, right? And I take my pencil and I follow it down. Do these line up?
Yes.
1/3 and 2/6?
Yes.
Yes, so that tells me they're equivalent. 1/3 is equal to 2/6. Okay, now I want you to try 22. Take your pencil, your marker, or whatever you're using, follow the star down and see if they line up. Did they line up?
Yes.
Yes, so that tells me 2/3 equals 4/6. Now, let's go back to what I said earlier. How can I check and make sure? I use multiplication, okay? So I'm going to go back over here. 1 times 2 equals 2. Is 3 times 2 equals 6? Yes. Okay, over here. 2 times 2 equals 4. Does 3 times 2 equal 6? Yes. So you have to be multiplying by the same number. I can't say, well, 2 times 2 is 4, but 3 times 7 is 6. If you multiply by two different numbers, then they're not equivalent. You have to multiply by the same number. Okay? Now let's go to 23. I take my pencil, I follow the star down. Does it line up with the other star?
No.
No, but still I want us to practice numbering the number line. So let's say they're not equivalent, but we need to say what two fractions we're talking about that are not equivalent. So how would I figure out what this star is right here? What fraction? Bryson?
Count the spaces.
Count the spaces. So there's 1, 2, 3, 4, 5. So 5 is my denominator. How do I figure out the numerator? Start at 0 and count to the star, right?
Yeah.
1, 2. So 2/5. Okay, now let's figure out the fraction for the bottom one. 1, 2, 3, 4 is my denominator. The numerator, 1, 2, 3/4. Okay, so let's use multiplication just to be sure. I have 2/5 and 3/4. I want to see if they're equal just by using multiplication. Can I multiply 2 by anything to get 3? 2 times 1 is 2. 2 times 2 is 4. So no, you can't multiply 2 by anything to get 3. So does that mean they're equal? No. Okay, good. All right, last one. I want you to try this one on your own. Tell me if they are equivalent or not. Okay, class. Do you think these number lines are equivalent?
No.
Ooh, I heard a lot of no's. Why not? Because they line up. If they line up, then that should make them equivalent, right? The stars line up. Bryson, what's the matter?
The lines are not equal.
Very good. The lines do not start at the same spot. I can't say these are equal if this one starts here and the other one starts here. Okay, because if Kaylee, because if I had pushed this number line back and started here, Because now this star is going to be more like here. So no, they're not equal. But what is a strategy we've learned to double check? We would do what? What did we just do on the first three? We multiply, okay? So let's label what fraction this is for the top number line. It is 1, 2, 3, 4. So 4 is my denominator. What's my numerator for the star? 1, 2, 3. So 3/4. And down here, it's already got it labeled for us. It's 5/6. Okay? We said no, they're not equal. So let's just double check. 3 times, does 3 times anything give me 5? Does 4 times anything give me 6?
No.
No. So they're not equal. Okay? So that's what equivalent fractions mean. They're equal. They represent the same amount. Okay? For number lines, those would probably be the only ones that would be a little bit tricky, right?
Yeah.
You got to make sure that they're starting at the same point. Okay? So now what you guys are going to do, you're going to get an assignment that looks like this. Okay? So let's review real quick everything we've learned. So this is what we learned the first 3 days, and then equivalent fractions is what we just worked on today. Okay? So 7 through 14, the end, you're trying to tell me if they're equivalent or not equivalent. That's all you have to do. So on the line out to the side, I want you to put equivalent if they're equal, not equivalent if they're not equal. If you're not sure, by just looking at the shaded parts, what can you do?
You could,
Kelsey?
you could multiply.
You can multiply, okay? Now let's go to the top part. We're comparing fractions. So what have we learned when we're comparing fractions?
Ooh.
If the denominators are the same, we look at the numerator. So same denominators. Look at the numerator. I'm just going to do eyeballs. Look at numerator. Okay? Same numerators, we look at the denominator. Good. And if the denominator is bigger, what does that mean?
Then it is that if the denominator is
Bigger denominator means smaller pieces. If you need to write this at the top to help you remember, you can. You also have your math notebooks that you can use to help you remember. Okay? So if the denominators are the same, you need to look at the numerator to tell you which one's bigger. If the numerators are the same, we look at the denominator. Okay? Any questions before we start?
Can I pass them out?